All right, your first test for quarter 4 is on Friday the 18th. That's the last day of quarter 3. So all of your other teachers are probably going to be scrambling to get stuff done. We'll be preparing for quarter 4 because, again, remember, quarter 4, especially for our seniors, super fast. Not a lot of time left. 8.1 is just introducing you to sequences and series. Kind of like the construction of them, what the terminology is, that sort of a thing. 8.2 is called arithmetic. And that has a specific meaning and way that we do it. And then 8.3 is geometric, which has a specific meaning in the way that we do it. So we're going to break it up in the next 2 sections. This first one is just kind of introducing you to things, the workings of it, and how to figure some of the things out. We're also going to talk about something called factorials. There's a button on your calculator. I'll talk to you a little bit about it today, but tomorrow's when we're going to evaluate them. When you're talking about a sequence or a series, right? An infinite sequence, it says, is a function whose domain is a set of positive integers. Guys, if you have an infinite sequence, what does the word infinite mean? It never ends, goes on forever. So it never ends, kind of like infinity, right? If you have a finite sequence, what does that mean? It ends. There is a specific beginning term, and there is a specific ending term. You'll have a finite series or sequence, right? Terms. Terms are like your values. If I say, what's the third term of a sequence or a series, you would count 1, 2, 3, tell me what the third number is, right? We talk about terms in terms of sub numbers, like a sub 1, that's term 1. A sub 2 is term 2, that sort of a thing. Okay? You understand that? I just want you to see the terminologies. N is your value that you're going to plug in for. You'll see in a second. So if I have questions like this, there's probably 8 of these on your website. Super duper easy as it appears. It says, write the first 4 terms of each sequence. This is what I need to see from you. I need you to say, okay, well, the first term, a sub 1 is, the second term, a sub 2 is, the third term, a sub 3 is, and the fourth term, a sub 4 is. And how you find that is this is your n that you plug in. So this would be 3 times 1 minus 2. Here, this is my n that I'm plugging in. The second term is 3 times 2 minus 2. Your third term is 3 times 3 minus 2. And your fourth term is 3 times 4 minus 2. That's you showing me you understand how to find the first 4 terms. And then you evaluate that. What's 3 times 1? Minus 2 is 1. 3 times 2?
6.
Minus 2?
4.
Good. 3 times 3?
9.
Minus 2.
7.
3 times 4?
7.
Minus 2.
7.
So the first 4 terms of this sequence is 1, 4, 7, and 10. Okay, I don't want just 1, 4, 7, and 10, and then you write, I did it in my calculator. I will not give you credit for it. You have to show me that you understand how to set it up and how to find those answers, okay? You'll also have some that are a little different. I want the first 4 terms of this one. So a sub 1 means I plug in 1, a sub 2, a sub 3, and a sub 4. When I plug in 1, I have 3 plus negative 1 to the first power, 3 plus negative 1 to the second power, 3 plus negative 1 to the third power, 3 plus negative 1 to the fourth power, right? We evaluate this, guys. It's a little different. Negative 1, we evaluate that first. What's negative 1 to the first power? Negative 1. So 3 plus negative 1 is 2. Negative 1 to the second power, 1. So 3 plus 1 is negative 1 to the third power is negative 1. So 3 minus 1 is, and then 3 plus 1 is, so here it's 2, 4, 2, 4. You see it doesn't go up the same every time? Because this is the rule for the sequence. We are going to learn how to write those rules. Given the terms, we're going to learn how to go backwards and write the rules. I'll show you 2 examples here in a second. Again, that's not really what we're focusing on today. We're going to do that more in 8.2 and 8.3, but just kind of learning the algebraic way behind it. Some of us like these things. You get stuff like this. It's like, what's the next pattern? Kayla, you need that? Okay, so something like this. Some of you are really good at this and some of you aren't. All right, I'm just going to give you a couple examples here. We're going to talk about this. Again, this is not really what we're focusing on in this lesson, but I have here the first sequence is 1, 3, 5, 7. And it says write a rule for the apparent nth term. Meaning if I said to you, what's the 540th term? You could tell me that. All right, well, you can. I know you guys can. Hold on, okay. You can tell me the next one's 9. How'd you get that? What are we doing from 1 to 3? Adding 2. What are you doing from 3 to 5? Adding 2. What are you doing from 5 to 7? Adding 2. This is called an arithmetic sequence. Arithmetic sequences are the same thing as a linear function. I'll show you how. If you guys think about this, right? When we found our different term numbers, right? We plugged in 1 into the rule, and we got out 1. So then when I found a sub 2, when I plugged it in, I got 3. When I found a sub 3, a sub 4. You could think of this as an XY chart. These are my X values, these are my Y values. Right? So if I was talking in terms of a linear function, what would you guys tell me the plus 2 is every time? It's your slope, right? So if you're writing something in y equals mx plus b, you need the slope and the what? Y-intercept. So you guys could tell me this is 2x plus. Well, how do you find the y-intercept? No, just look at it. Plug in what? What do you guys plug in? If you're finding the y-intercept for anything, what do you plug in for x? Plug in what? 0. You plug in 0 for x. So you find the 0 term. If you're adding 2 to get to the next term, how would you find the one before it? Subtract 2. So what's 1 minus 2? Negative 1. So there's my rule. In arithmetic terms, you guys would say your rule is a sub n equals, instead of x, use the n minus 1. We'll talk this. We're not learning this lesson right now. We're just thinking through it. There's a formula for it. Not right this second. We're just thinking about it. But think about it. So if I said to you guys, instead of, at the beginning, I said, what, the 195th term? And you're like, I can tell you the next one. Well, you don't have to go from 7 and just add 2 190 times. You could plug right in here. I want the 195th term. So you would say 2 times 195 minus 1. What's 195 times 2? 390 minus 1. So the 100, guys, the 195th term would be 389. So like I said, instead of sitting at your SAT and going, okay, I'm going to just keep adding 2 or whatever, I'll just circle C, you can actually write a rule for it. And there's different kind of rules. We're going to talk about arithmetic, which is what this one is, whether you add or subtract, the same thing every time. Geometric is when you multiply by the same thing every time. I just want you guys to see this. Like, look at the next one. It's 2, 5, 10, 17. Yes?
Why do they even give us on our SAT when
But okay, let's look at this. What do we do? How did we get from 2 to 5? Okay, this is plus 3. How did we get from 5 to 10? Plus 5. How did you get from 10 to 17? Plus 7. So you guys could figure out, what are you going to add to the next one? Plus 9. Then you would add 13. Okay. Again, I'm not trying to get you guys to know how to do this right now. I'm trying to get you to think a little bit. Algebraically, you guys first found out, this is called the first difference. It wasn't the same. So we found the second difference. Since the second difference is 2, that indicates it's a quadratic function. Some of us could look at that and see the relationship between the numbers. It's okay. We will learn how to algebraically find all of that. I promise. I just want you to see it. That's it. Just relax. All right. We're skipping ahead. In your notes, I know there's recursive formula. We're going to talk about that tomorrow. And there's factorials. You have something like this. That's not just an excited way to say 7. There's a button on your calculator that is factorials. But what all this means is 7 times everything behind it. So 6, 5, 4. It's just a shortened way to write it. So you're going to evaluate using factorials. It's not a major deal. We'll do it tomorrow. But when we're talking about the summation, what does the word sum mean? Add. If you're finding or using summation notation, okay? This is all very basic. These are the problems that go with summation notation. If I asked you guys right now to do these, you'd have absolutely no idea what's going on. All right? This is the Greek letter sigma. A lot of you will become familiar with that next year. Whichever Greek organization you join, you'll see sigma stuff. But what this is adding all of the terms together. That's all this is. You're going to have the index of summation. You're going to have your upper limit and your lower limit. Guys, where does it make sense that the upper limit is located? Above the E or below the E? Above. Where is the lower limit? Below. You have a question?
Yes.
What's up?
Would you use this like in a real life situation, like probability?
Yes. We're going into probability in the next few. Yeah. So if you have a question like this and it says sigma notation for sum, find the sum, whatever. All this is telling you guys is here is the function that they want you to use, 3i. And they want you to evaluate. What number do they want you to start plugging in? With 1. What number do they want you to stop with? 5. You got to plug in all the ones in between. So 2, 3, and 4. This is all this is saying. Summation means you get all those answers and do what? So this is what you would show me. 3 times 1. 3 times 2, 3 times 3, 3 times 4, and 3 times 5. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, correct? When I sum those up, what's 3 plus 6 plus 9 plus 12 plus 15? So your answer here would be 45. That's it. So now is this one a little easier to do? Yeah. Now that you see, okay, what's the lower limit? What's the number I'm going to start evaluating with? 3. What's the upper limit? 6. And I'm going to plug in 4 and 5 along the way. And then what do I do with all of those answers? I add them together. So you would show me, okay, 1 plus 3 squared, 1 plus 4 squared, 1 plus 5 squared, and 1 plus 6 squared. Oh, I put my squared in the wrong spot here. This should be here, not there. What do I do first? Add them together or multiply? I'm going to square it. I'm going to say 3 squared is 9, plus 1 is, yep. 4 squared is, plus 1 is, 5 squared, plus 1 is, 6 squared is, plus 1 is, and then I sum them together. And what do I get? 90. And that would be your answer. That's it. Now, on your web assign, you might have one that says this. Whoa. Say the upper limit is 5, the lower limit, and you have this. You guys like, wait, huh? I don't know. She never went over this. I don't know what's going on. How many 8s do they think they want that you need to add together? 5. When they don't give you any number to evaluate, you say the upper limit is starting with 1. How many 8s are there? 1. And I want to have a total of how many? 5. So you would just multiply 8 times 5 is 40. Whenever it's just a single number and there's nothing to go along with it, that's it. Sound good?